Hi everyone, good morning. So in the last session we have discussed about the properties of fluids, the first module, the complete introduction about the fluid mechanics. So now in the second session it is going to continue with again the primary properties and the secondary properties. So what we have discussed the primary properties of fluids. In the last session there are in the primary properties there are four properties. The one is mass density that represents by rho. And second one is weight density that is represented by small letter w, and the third one is specific gravity that will be represented in terms of capital letter G or capital letter S. Then the last one, specific volume, that represents S suffix V. So we know that we have discussed the mass density and the weight density in the last session. That is, mass density will be represented as rho, and mass density is the property of the fluids. It is the ratio of mass of the fluid by volume of the fluid. So mass will be represented by M and volume will be represented as V. So mass by volume. So mass of the fluid by volume of the fluid is known as mass density of the fluid, and it will be represented as kg per meter cube. Then the second one is weight density. So weight density is the ratio of weight of the fluid by volume of the fluid. So again, weight will be represented as capital letter W and volume as capital letter V. So W by V, weight of the fluid by volume of the fluid, is known as weight density of the fluid. So that will be represented as Newton per meter cube. And the third one is specific gravity. So specific gravity, it is the ratio of mass density of the fluid by mass density of standard fluid. So I told you in the previous introduction class, standard fluid is water. So for the water, specific gravity is 1 and mass density is 1000. So whatever will get it to find out the particular property of the fluid. So that will be calculated here. I'll show that example. So mass density of the fluid, mass density of the water. We have to calculate what is the specific gravity of water. So to find out that, if you know what is the mass density of water is 1000 divided by mass density of standard fluid, again it is water, that will be 1000. So both will get cancelled and you will get the specific gravity is 1 for water. And there is no SI unit because both the units will get cancelled. Here if you are taking in terms of mass density kg per meter cube, here it is kg per meter cube, both will get cancelled, then there is no unit. Again, the specific gravity can be calculated in terms of weight density of the fluid by weight density of standard fluid. So the weight density of water is 9810, again it is 9810. So again it will get cancelled and you will get specific gravity is 1. So vice versa, if you know the mass density of any particular fluid, that can be multiplied with the standard fluid. So now I will take an example with oil. For example, the oil specific gravity is 0.7. Calculate what is the mass density of the fluid. Then you can just do multiplication. So if you know 0.7 is the specific gravity of oil and we know what is the mass density of standard fluid is 1000. So 1000 into 0.7, that will be 700. So 700 is the mass density of oil. So these are all the examples will be taken to calculate the specific gravity. So sometimes in the numericals they will give you the specific gravity, then you have to find out the mass density, or they also calculate the weight density. So these are all the primary properties which help you to find out in terms of specific gravity. The last one is specific volume of the primary property. That is, specific volume will be known as reciprocal of mass density. So S suffix V represents 1 by rho. It is nothing but rho is represented as mass density. So if you want to find out the specific volume, it is the reciprocal of mass density, that is 1 by rho, or volume of the fluid by mass of the fluid. Then the unit will be meter cube per kg. SI unit for specific volume is meter cube per kg. So these are all the four important primary properties. The next one is secondary properties. So when it belongs to the secondary properties of the fluids, in secondary properties, viscosity, So in viscosity there are two classifications: dynamic viscosity and kinematic viscosity. Compressibility, surface tension, capillarity. These four are the secondary properties of fluids. So what we have discussed in the primary properties: mass density, weight density, specific gravity, specific volume. So similarly in the secondary properties we should know what exactly the viscosity means. It is the another secondary classification of the fluid. So one asked you to find out the viscosity of the fluid. So viscosity is also will be say as dynamic viscosity. So what do you mean by dynamic viscosity? So well, there will be of a fluid, there will be of two layers. So if you're considering any kind of fluids, if it is flowing, we can see that if you just flow a water on the floor, as well as if you just flow on the oil on the floor on the same surface with the same elevation, we can say that with the same gradient. But there will be of difference. The water which is flowing more than, or we can say the faster than oil, because the oil properties were different and the water properties are different, but both will be fluid. The same way, what exactly that property and how it is going to be changed. So in terms of viscosity, when there will be of two layers, if we are considering when there will be of two layers, so if it is in equilibrium, for example, when that the upper layer is moving in one direction, the bottom layer which has to resist, it has to flow in the same direction, but it has to resist in opposite direction to maintain an equilibrium. So when it is flowing in this plane and bottom layer, if it is going to oppose in the other direction, there will be a friction. Means when there will be of two layers which causes the friction, there will be of a stress. So what type of stress? There will be of a shear stress. So that when there will be a stress, there will be a strain. So when the shear stress is directly proportional to shear strain, then there will be of a viscosity. So what exactly that is? So that will be represented in terms of the mathematical equations. That is, tau represents in terms of shear stress, and now I can say the example, the two layers. We can say here there are two layers. Here it is traveling with a velocity of u, and here it is going to travel in opposite direction as u plus du. So now in between the thickness of the layer is dy. So we can see the thickness of the fluid between the two layers is dy, but here the velocity which is going to pull, which is going to push it, the upper layer is u, and which is going to push it in the opposite direction, that is u plus du. And if you take the difference, you will get cancelled and you will have only the change in velocity, that is du. So if you are considering there is a strain, then the strain will represent as du by dy. And if there is a stress, then shear stress, that is represented as tau, then shear stress is directly proportional to du by dy. Then what we can say, when the shear stress is directly proportional to du by dy, the shear strain, or we can say it will be as velocity gradient, then shear stress is equal to mu into du by dy. So here mu represents it as dynamic viscosity. So if you want to find out what is the dynamic viscosity, then we should remember this equation. Tau is equal to mu into du by dy. Du by dy is shear strain, tau is shear stress, mu represents it is the viscosity coefficient, or what we can say the dynamic viscosity. Then the second one is kinematic viscosity. So kinematic viscosity will be represented as nu, and kinematic viscosity is the ratio of dynamic viscosity by mass density of the fluid. So mu represents the dynamic viscosity and rho represents mass density of the fluid. So when it belongs to dynamic viscosity of the fluid, that will be represented as mu, and the unit is SI unit is Newton second per meter square. We know the stress is Newton per meter square, and du by dy that represents velocity gradient, or we can the shear strain. Shear strain, du is velocity meter per second and dy is thickness, that will represent as meter. Meter will be cancelled. It is only Newton second per meter square. Then that this is SI unit, or there is one more unit, poise, that will be represented in terms of CGS unit. So here, when it represents for dynamic viscosity, kinematic viscosity, it is the ratio of dynamic viscosity by mass density of the fluid. So for that, SI unit is meters square per second. Okay. As well, then ask you to find out in terms of CGS units, that will be Stokes. So this is belongs to the secondary properties of one of the properties, viscosity, and that dynamic viscosity and kinematic viscosity. So before going to the next one, compressibility, surface tension and capillarity, that we can discuss after the numericals from the primary properties. Okay, so in this second session, it's about the primary properties and the introduction about the viscosity. So in the next session, we can discuss about the numericals with the primary properties and the secondary properties. Thank you.